Hello friends, welcome to Finance Logic channel. My name is Evgeny. Let's study finance using logic together. And today we're going to talk about internal rate of return trap. It's a bit advanced video, but if you don't know what internal rate of return is, this video may be also useful because we start with the basic. We spend some time to talk about very basic things, what internal rate of return is. Internal rate of return, it is investment return that we measure in percentages. Let's assume that we invest today 100 and we expect to receive 110. It doesn't matter where we invest, it doesn't matter about the instrument. It matters that we invest and we expect to receive benefits as a result of our investment. And if 1 year we expect to receive 110, our internal rate of return is 10%. We expect to earn 10% per year. We estimated it just comparing these two numbers. We need to find the rate at which we have to increase our today investments to get future cash. Or if we make a simple substitution, we can say that today's money equals to future money divided by 1 plus IRR to the power of 1. So as you can see, IRR is very simple to estimate if we have a very simple project. We have only today investments and one future inflow. If we have more sophisticated project, if it lasts 2 years, in year number 2 we expect to receive benefit of 16. In this case we cannot estimate IRR in our mind very fast because we have to solve the following equation. We need to estimate the rate that makes equal today money to discounted future benefits. In this example, IRR is almost 23%. So, if IRR is 23% per year, it means that we have a 2-year project and we expect that our project brings us a return of 23% per year. We say that we invest 100 at 23% annually for 2 years. This is very important when we interpret IRR, to specify the period. We have a return and we have duration of our project. Now let's say another example. Let's say that our project lasts 3 years and we also expect to earn 9 in year number 3. In this case, estimations are more sophisticated and IRR here is 28% per year. So we say that here we invest 100 at 28% annually for 3 years. So this is how we generally interpret IRR. But here we have some kind of trap that we are going to solve and we are going to pay attention on. But before that, I have to mention that we can always use Microsoft Excel to estimate IRR. All we need to do that is to input our cash flow pattern and apply formula IRR or XIRR if we have more sophisticated cash flow pattern. So now let's take a look at our 3 examples that we have just observed. First one, project lasts 1 year and we have 10% IRR. Second one, 23, and project lasts 2 years, and third one, 28. Try to forget for a moment about the math. Just compare the results with the project themselves. Look at the third one and compare it with the first one. We have some additional cash flows of 16 and 9. These sums are not so significant, and we don't have these amounts in project number 1. And our IRR is 28%. Comparing with 10. So what I want to say? I want to say that if we compare our 3-year project with our 1-year project, we can say that to 3-year project we have added additional inflows that are not so high. they are quite insignificant, 16 and 9, only 16 and 9. They are not so significant comparing to initial investment and comparing to cash flow benefit in year number 1. But our internal rate of return is almost 3 times higher comparing to project that lasts only 1 year. So how is that possible? Does it mean that our numbers are wrong or not? The fact is that we need to understand in more details what IRR is. Let me give you another picture. Let's compare the following projects. Assume that we have 3 projects. First one lasts only 1 year and duration of second and third is 2 and 3 years respectively. Internal rate of return of all this project is the same if we apply net. It's 10%. But the first project is closed after the first year. But second and third are still functioning, but with zero result. Is that important? Do we need to take care about the project? The project still works, but the result is 0. Of course, yes. We need to take care about it, and we need to take it into account when we interpret internal rate of return. So the key thing in avoiding this trap that was in the title of our video is to apply a right interpretation, to use proper interpretation of what internal rate of return is. Before we have a solution of this problem, let's take a look at another example. Let's assume that you have 2 investment projects that are mutually exclusive and you need to choose. Your investments are 100 in both cases and you have 2 different cash inflows patterns. What would you prefer? Internal rate of return, if I say you is the same, 10% per year. If we estimate IRRs are the same, but do you see any difference between these 2 projects, between these 2 cash flow patterns? Of course, the difference exists. And let's take a look in more details about it. The first difference between these 2 projects is that second project promises me more money. And this is advantage of second project. Now let's try to find any advantages of the first one. The advantage of first one is that we receive money in year number 1 and we call it intermediate cash flow. So we receive money faster comparing to project number 2, comparing to the second one. This is advantage of first project. So what would you prefer if returns are the same? Would you prefer fast money or would you prefer big money? The answer is it depends. It depends on the situation. It depends on the project risks. If project risks are high, it's better to get money as fast as possible. So quick cash is better. If risks are low and I'm quite sure about my forecast, then I can wait, and inflation is low, I can wait, and I want to receive more money for that. So it depends. It depends on the project risks, and project risks are not incorporated in IRR estimation, because all we need to estimate IRR is cash flow pattern without any discount rates or anything like that. So now let's go back to the numbers and try to answer why IRRs are the same. Let's think about the first project. We receive, in year number 1, we receive cash benefit of 80, and what do we need to do with this money? So what is next? The project still lasts, it's not finished, and we need to do something about this money. Let's assume that we reinvest this money for 1 year at 10%. Technically it means that we have $80 of cash inflow, and at the same time we have $80 of cash outflow as investments. And instead of getting 80 at the end of year number 1, we get 80 plus 10% at the end of year number 2. So in total we have the following cash flow pattern. We have 0 in year number 1 and we have 121 at the end of year number 2. So assuming that we reinvest intermediate cash flow at 10%, our cash flow patterns in both projects are absolutely the same. And that is why IRRs are the same. Now let's imagine that we get 80 and we are able to invest it for 1 year till the end of year number 2, but only at 5%. In this case, instead of getting 80 in year number 1, we get 80 plus 5% and it's only 84. And our cash flow pattern looks like this. We get at the end of year number 2 117. Now let's re-estimate IRR. What IRR is in this case? In this case, IRR is only 8.2%, comparing to second project that promises 10% per year. So what is the conclusion? The conclusion is that IRR, by its nature, automatically assumes that all intermediate cash flows, if we have ones, are reinvested at IRR till the project ends. In second project, we don't have any intermediate cash flows and we don't have any kind of problems associated with that. So we started discussion of this example saying that IRRs are the same, but now they are not the same. Let's go back and let's offer some kind of solution. So here the solution is to be very carefully about IRR of first project, saying that it's 10%. So we need to put a special glasses to avoid wrong view. So the interpretation is as follows. Technically IRR is 10%, but our annual return is 10% only if we can reinvest intermediate cash flows. In this case it's $80 at 10% till the project end. So at 10% till the end of year number 2. So this is very important to understand. So this is a proper interpretation of IRR where we have intermediate cash flows. And we don't have to mention the same for the second project, because for the second project we don't have intermediate cash flows. So to avoid trap, we always need to be aware of the IRR assumption. IRR assumes that all intermediate cash flows are reinvestment at IRR till the end of our project. Now let's see an example that shows where our interpretation IRR is the most important, or the trap is more dangerous. Let's assume the following project. We invest today 100 and we expect 297 in year number 1 and 10 in year number 2. So we have a 2-year project. It doesn't matter where we invest. It may be some personal investments, it may be some financial investments or investment in a real business, whatever. It's very important to understand what IRR tells us. IRR technically here is 200%, so it's a great project. It seems great because we invest $100 at $200% per year for 2 years. But in fact, we are able to earn 200% per year only if 297 are reinvestment at 200% till the project's termination. So for 1 year more we need to reinvest 297. IRR here is quite high, and I guess that it's very difficult to find some 1-year project where we can get so high return, because amount of 217 is so high, and it's very difficult to find investment that gives us 200% per year. Now let's have a look. What if we do nothing about 297? What if we just put it in a safe box till the project end? In this case, it means it is the same like we invest 100 and we get in 2 years 307. 307, it is 297 plus 10. So if we re-estimate IRR, it's only 75% per 2 years. So if we do nothing with intermediate cash flow, our real return, our real IRR, we can say so, is 75% per year. So IRR assumption is more dangerous when we have significant intermediate cash flows, and it makes this reinvestment, it makes our total return very sensitive to this reinvestment assumption. So we need to be careful with interpretation of IRR when we have intermediate cash flows, and then these intermediate cash flows are very significant. Now let's go back to the beginning and let's make a proper interpretation of our IRR metric to our projects. In our project, which lasts 2 years, IRR is 23%, but we need to add that our annual return is 23% only if 110 are reinvestment at 23% for 1 year, till the end of year number 2. In our project that lasts 3 years, the same. Our annual return is 28%, only assuming that 110 and 16 are reinvestment at 28%. 110 we have to reinvest for 2 years, and 16 we have to reinvest for 1 year till the end of year number 3. So this is very important to understand, that IRR is not the same as our real annual return that we can get if we have cash flows as expected. So this is very important to add, at least in your mind, when you talk about IRR. So to avoid the trap, keep in mind that IRR automatically assumes that all intermediate cash flows are reinvestments till the end of a project. And that is why IRR should not be used as a basis of selection between mutually exclusive projects. So we need to use another metrics. Why do we still need IRR? IRR is still very useful. It's easy to understand because it shows us annual return. We only need to remember about reinvestment assumption. And IRR is good for analysis of investments with low intermediate cash flow, because that makes reinvestment assumption insignificant. So now it's your turn to show how you understood what I have told you, and you will have 3 short multiple choice questions. Only one choice is correct, and you will have 15 seconds per question, but you always can stop me if you need more time. So let's begin. Question number 1, very simple. What is the major weakness of IRR? Only one choice is correct. So let's go through our options one by one. It has a relative nature. Actually, it's not a weakness, it's an advantage. It's hard to estimate if a period is long. If a period is long, it's not enough to say that it's hard to estimate, because we have at least Microsoft Excel financial formulas that helps us to estimate IRR in a second. So it's not a weakness. Option D, it works only for annual cash flows. In all our examples assumed annual cash flows, but in real life we may have monthly cash flows, quarterly cash flows, or whatever. IRR can be estimated on any cash flow pattern, whatever it is. So D is not a weakness. And the major weakness of IRR that is the reason of trap that we may have is reinvestment assumption. IRR assumes that all intermediate cash flows are reinvestment at IRR. So I hope that you answered C. Let's go to the next one. You have the following project. You invest 100 today, and in 2 years you expect to receive 120 and 20. What is IRR? But don't use Microsoft Excel or any other help. Try to focus on reinvestment assumption and try to eliminate answers that are not correct. So don't use Microsoft Excel, don't use any other help. So try to think and focus on possible options. 15 seconds. So let's take a look at the numbers. If we invest 100 and we get 120, it is 20% per year. Because IRR has reinvestment assumption. So we assume that we can reinvest 120 till the project end. So it means that IRR of this project cannot be less than 20%. Because it's 20% when we invest 100 and we earn 120, and that's all. In this case, we have 120 and also we have 20 in year number 2. It's additional cash flow that makes our IRR more than 20. So obviously we can exclude B and D. Now we have to choose between 50 and 35. Let's create cash flow pattern that shows how 50% IRR looks like. So it looks like this. We invest 100, we get 150 and 0. So we get 150 in total in year number 1, and we have 0 in year number 2. Let's compare this project with our project is less attractive because in total we receive 140 and we receive it in 2 years. Of course, it's always better to receive 150 in year number 1 than 140 during 2 years. So that is why IRR of our project cannot be 50%, it's less. So that's why we exclude A, and correct answer is C. That's quite sophisticated question, not so easy as previous one, but I hope that it helps you to understand nature of IRR and reinvestment assumption. Let's go to question number 3. What investment to choose? You have two investment opportunities, project A, which has IRR 31%, and project B that has IRR 29%. It's very important to note that these projects are mutually exclusive, so we need to choose only one between them, and they assume zero inflation environment and no risks. What project to choose? B, as it has more inflows, A, as it has the highest IRR, C, A, as it recovers faster, and B, as it has no reinvestment assumption. 15 seconds to think about that, or you can stop if you need more time. Let's take a look at option B. Option B says that A is better as it has the highest IRR. IRR should not be used in making decision when we select between two mutually exclusive projects. That is why B is not right option. Let's take a look at D. D says that B is better, project B is better, as it has no reinvestment assumption. Project has no reinvestment assumption only if it has no intermediate cash flows. Project B has intermediate cash flows, they are not so significant. These are two cash inflows of $5 in year number 1 and year number 2, but it has reinvestment assumption. So we eliminate B and D. So now let's take a look at very important information in the scenario, information about zero inflation environment and no risks. It assumes that when we have low or zero risk, it's always better to receive more money. When we have zero inflation and no risks, it means that money in future are almost the same as money today. That is why it is better to receive more money but later than less money but faster. So in this case, project B is better because project B has more cash inflows. We expect to receive 210. If we compare it with project A, that promises only $135. So project B is better. Now, homework for you. Write in the comments your possible solutions, opinions, or whatever. You need to borrow, pay attention, to borrow, not to invest. And you have two options. You have to borrow 100 and you have two cash flow pattern relating to your repayments. What would you choose and why? First option, option A, that assumes the effective rate that is the same as IRR, 10% per year. So you take money today 100 and you have to return 80 and 33 in 2 years. Or you take 100 today and you have to repay 121 at the end of year number 2. So what would be your choice, considering that effective rates or IRRs of these cash flow patterns are the same. It's very important to recognize that there is no one obvious answer. You have to say that I would prefer option A, and in what circumstances, or option B, in what cases. So I'm inviting you to write in the comments to this video your solution. I will try to provide feedback to all of you. Let me know whether this video is useful. Let's study finance through logic together, and see you on our next videos.